Let's take a look at lines and planes in space. So first we'll take a look at lines in space and how to represent them. So there's two ways to represent a line in space. We have the parametric or we have the symmetric equations. So first, the parametric equations are going to be in terms of t. We're going to represent the x value in terms of t, the y value in terms of t, and the z value in terms of t. So first, what do these x1, y1, z1, as well as the ABC refer to? So the ABC is the component form of a vector that's parallel to the line that we have. And then finally, the x1, y1, z1 is a point that is on the line itself. And we'll install updates later. But so it's kind of like if we have in 2D, it's kind of like point slope form. We have the point, which is on the line, and then we have the slope, which is kind of the vector that is parallel to the line, if you kind of want to think about it that way. And then we basically derive the symmetric equation from the parametric equations, and basically how we do that is we just solve for t. So we just do x, we move x1 to this side, and we divide the whole thing by a. Same thing with y, and same thing with z. We set them all equal to each other, and that's how we get the symmetric form of a line in space. So let's try an example. Find the parametric and symmetric equations of a line passing through these 2 points that are given to us. So the first thing we want to do is find the component form of the vector that is parallel. That is parallel. So we'll do that. So it's going to be 4 minus 1, 0 minus 3, 1 minus negative 2. It's going to be 3, negative 3, and 3. And we'll pick this point just because it's the first one. And we will make the parametric form of the equation. So that's going to be x is equal to 1 plus 3t, y is equal to 3 minus 3t, and then finally z is equal to negative 2 plus 3t. That's going to be the parametric form of our equation. And then finally the symmetric form, we're going to solve for t. X minus 1 over 3 is equal to y minus 3 over negative 3, which is equal to z plus 2 over 3. That's going to be our symmetric form of a line passing through these points in space. And we want to note that there are infinite ways to represent this line. There are infinite number of answers if we just use a different point. So if I use this point, for example, I'd have a completely different representation of that same line. So you want to keep in mind that there are infinite ways to represent this one line based on whatever point that we choose to use. Looking at planes now, the standard form of equation of a plane in space is going to be a times the quantity x minus x1 plus b times the quantity y minus y1 plus c times the quantity z minus z1 is equal to 0. The point x1, y1, z1 is a point on the plane itself. Okay, it's kind of similar to the equation of the line in space. And then the vector ABC is going to be a normal vector to the plane. So what is a normal vector? A normal vector is just something that is orthogonal or perpendicular to the plane. So we know how to find a vector that is perpendicular to something. We just take the cross product. So let's do that in this example. Find the equation of a plane passing these 3 points. So first we want to make 2 vectors. And what we're going to do is we're going to pick these 2 points and these 2 points and make 2 vectors, find the cross product of them, and then we can use one of the points to put it in standard form. So let's do that. 1 minus 3, 5 minus 2, 0 minus 2, That's going to be equal to negative 2, 3, negative 2. And then finally this one, 1 minus 3, negative 3 minus 2, 1 minus 2. That's going to be equal to negative 2, negative 5, negative 1. And then we will take the cross product of that. So I, j, k, negative 2, 3, negative 2, negative 2, negative 5, negative 1. And using the cofactor method, I, 3, negative 2, negative 5, negative 1, minus j, negative 2, negative 2, negative 2, negative 1, plus k, negative 2, 3, negative 2, negative 5. Negative 3 minus 10 is going to be negative 13i. 2 minus 4 is going to be negative 2. Negative becomes a positive. 2j. 10 minus negative 6, so that's going to be 10 plus 6, plus 16k. And we'll find the equation of the plane now by basically plugging it in. So we have the normal vector right here, and we have a point on the plane. We'll pick this one. So let's do that. So A is going to be negative 13, x minus 3, plus 2, x minus 2, plus 16, x minus, correction, z minus 2, and this is going to be a y, not an x. Z minus 2 is equal to 0. So this is what we call standard form. Now what we're going to do is we're going to multiply it out so we can get it into the general form. So the thing with the plane is that no matter what point we use, we will always get the same general form. We'll end up getting the same general form. So we have negative 13x plus 13 times 3 is 39 plus 2y minus 4 plus 16z minus 32 is equal to 0. Bring it over, negative 13x. 39 minus 4 is 35. Minus 32 is just going to be 3. So we'll put plus 3 is equal to 0. Plus 2y plus 16z plus 3 is equal to 0. We're not done yet, though. We always want to have the leading coefficient, in this case, the coefficient of x, positive. So we're going to multiply or divide by negative 1, however you like to think about it. I'll move this up here so we can see it better. It's going to be 13x minus 2y minus 16z minus 3 is equal to 0, and that's going to be our final answer.